Now this part I'm going to start off with. We're going to explain the term of small change of y to small change of x, also known as del y del x. How is that relationship? What does it do? What it does, and what does it represent? Then followed by how to get dy dx by using equation. Now assume you have a graph of in the Cartesian of a curve, and you have 2 points A and B in this curve, and you want to join this 2 point A to B, a straight line. You will get a gradient if you join these 2 points. The vertical will be the small change of y, the horizontal will be the small change of x. As when the point B moves, yes, like locus, it moves. As the point B moves along the line, go down and reaches A, what happened is this line shortened. What happened is you would get a line that is touches at only A. At this moment, this is a time where your limit or small change of x reaches 0 for this del y over del x. And at this instance, when it's a tangent line, at point A, is limit of del x towards 0, del y, del x, which is also equal to the dy dx. It's dx. So in short, dy dx represents the gradient at a point, at a given point, at a given coordinate or given point. Gradient at a given point for a curve. If it were to be linear, then things would be much more easier. But when it's curve of a given equation, then the gradient at particular point A, is different than when the point is at other places of the curve. To start off with, let's name it as a law or equation for various types of equation you might get in SPM. I would say this is kind of a law. First derivative. Law, like this is a law, there's always a certain law. It's not a law, but it's an equation. There are 3 types of them. Let's say A says you have a line. Y is equals to a constant number. It's just a number. If you were to differentiate it, you want to get a gradient of a curve, dy or dx. Straight away that will be, well, d over dx of k. There's no x here, so therefore straight away will be equal to 0. Now if you come back to this kind of curve, you refer to here, what happened is if you have a line, x, 0, y equals to a number. So it says I have a line that a constant. So this is maybe 10. So this line would be y equals to 10. If you want to get a gradient for a straight line, horizontal line, straight will come to your mind is 0. So therefore dy dx will be equal to 0. A horizontal line. There is no change of y. for this case? No change. They could have a they could have a change of del x, but there's no change of y. Says you have a point here, a point here, and a point here, A and B. So the gradient, the y's remain the same. So therefore, differentiate a constant d over dx of 10, it will be equal to 0. There's no change of x, no change of y. That will be the first law. Simple, first one. Next, I will show you on what happened. You get more practical example. B. Y equals to AXN. This law is aka also known as the functional law, also the function, or some technical glitches, xn, or y equals to a function of x power n. I will show you an example later. So you want to differentiate it, you want to get gradient at a certain point, a general equation of a gradient. How do you get general equation of gradient? So dy over dx, therefore b equals to d over dx of everything inside. And the rule would be, you bring down the n, bring down this n, bring it down, and you subtract with 1. You subtract 1 from it. So it will turn out to be a remain, and the number you have x n minus 1. Subtract 1. Example says you have y equals to negative 3x squared. In order to get dy dx, that would be, bring down the 2, that would be negative 6 x. 2 minus 1 is 0. That's how you get it. Or how about in this form, the function form? Dy dx would therefore be just like the same. You bring down the n, this n, bring it down, subtract 1, will be n. No, I want to take a 1, n, bring it down, then followed by whatever inside a function, n minus 1. Now, you can't show it here, but here would be much more obvious. You need to times, actually, times, differentiate whatever inside this square bracket, meaning you differentiate again whatever inside the fx. Let me show you an example. For instance, if you were to have a function, example, y is equal to 2x minus 3 power 2. You may of course expand it and then you differentiate it, but for this purpose, to show you on how to use this equation, let's use it. So dy over dx would therefore be, you bring down the 2, you times whatever inside, 2 subtract 1 is 1, so it's 1. Therefore, you doesn't need to write 1 if it's 1, but for the sake of learning, we'll do it. Times, differentiate whatever inside. Differentiate whatever inside here. So, differentiate whatever inside. Differentiate 2x minus 1 is like here. You differentiate this, you get 2. So 2x minus 3, you get 2. You get nothing, constant, so you get 0. Differentiate 2x, you get 2. Therefore, your answer is supposed to be 2 times 2 is 4. 4 times 2 is 8. 8x minus 12 should be the answer. It's pretty simple. I hope you're still with me. Now, next, C. You may want to pause this video and then proceed to do any question or in the reference book to practice on this part. Part B is quite an important step in doing performing differentiation. You may pause this video and bring up some exercise and try some of the questions and check with the answer key in your reference book or in your exercise book. Now next would be another simple one, is a combination. Why, let's say you have two different functions, a function u and a function v. Okay, something plus another function like here. A function, equation u and this is v. What happens if it's an operator? Plus and minus. It's simple. dy over dx, straight away you differentiate individually. du in terms of x plus dv differentiate in terms of x. You should get the answer. Example, I think you may refer to the previous, or maybe I find a simple sample for the purpose of this work here. It says let me use the previous equation that I've been using it in chapter 2 and 3 of y equals to what, x squared minus 3x plus 2 uvw. You have three different 1, 2, 3 terms. So you want to get dy dx. What you can do is you differentiate individually. You differentiate. You're going to differentiate this one, this one, this one, and this one individually. You treat them as an individual term, like what you have here. So you differentiate first one, you will get 2x, yes. If you are reading this, you understand what we have done earlier. Would you be able to tell what happened if you want to differentiate this negative 3x? You differentiate negative 3x, you will get, yes, negative 3. I hope you can do it. I hope you know the answer. And what happens is a constant is a number. Constant is a number. If you differentiate a constant, a number, what you get 0. That's why the answer should be 2x minus 3. C. D. Now, D would be a little bit more complicated than usual. I mean, as usual, it's a UV equation. D. Y equals to U times V. Now, if Y equals to U times V, that might seem a little bit too complicated, but it's not at all because there are some rules to remember it. You dy dx, you need to differentiate every individual one, but it's at times what you do, you differentiate the back, remain the front, then you plus, okay, you differentiate the back, dv over dx in terms of x, differentiate whatever at the back, times with whatever remain the same, and then in the front, and you plus, differentiate the front, remain whatever behind you. So every term get a share to be, it's fair. Every term get to be differentiated. They get to be, that you will differentiate every one of them. Example, we have says u and v is have a function y is equals to 2x squared plus 3 times 4x squared, maybe minus 2. You may, of course, it's a very simple equation. You may expand it and then differentiate by using the third method individually. You expand it, differentiate individually. But for the sake of this purpose, this UV, I'm going to show you on using it. How you do that? First, you have this kind of equation, and you doesn't know how to expand it. What you can do is you denote let. You let u to be 2x squared plus 3. V is 4x squared minus 2. Then what you do, you differentiate individually. Du over dx would be 4x, constant is 0. dv over dx would be equals to 8x. Differentiate a constant, you get 0. Then things would be easier if you have this, you write down this way, you cross multiply them, and therefore your dy dx what's there? So my dy dx this is v. dy dx would be therefore be, you just, according to here, copy this one times to this one, so that would be 2x squared plus 3 times with this one times with this one, that would be 8x, this term and this term, this x, plus this term 4x squared, this is my 2v, subtract, it's times with 4x. You expand it and you rearrange them, and therefore would be what? 16 x cubed plus 24x plus 16x squared x cubed minus 8x, and then the answer would be what? 32 x cubed plus 16x plus 16x should be a final answer. I accidentally draw this. This is du dx. So, need to apply a little bit more pressure on my eraser. Okay, so this is the fourth method I'm going to show you. The fifth one, E, last one, equation, no, second last, E would be, what happened, you have times, here we have dy, u, v. If u and v, what you do would be, if you differentiate it, you can't expand it, you can simplify it, you need to use equation. What you're going to do would be, you differentiate whatever at the front, remain v du over dx, you subtract with u dv over dx. It's on top, so you differentiate whatever on top, you times whatever below here. So you have V, this is V, differentiate. Erase off this. This is my V over V squared. Okay, so this part will be tricky because you need to differentiate first one first. Okay, example, let's say I have y is equals to what, 1 plus 2x over x squared minus 3. So you can't simplify this, therefore you let u is equal to 1 plus 2x, v is equal to x squared minus 3. Then du over dx is equivalent to 2 because it's constant. dv over dx will be equal to 2x because this is a constant, you get 0. And then you put them into the general equation, therefore dy over dx is equivalent to, you need to write this now so that it will be here and here, therefore it will be x squared minus 3. I have 2 times subtract 1 plus 2x over v squared. That will be x squared minus 3 squared. Remember this because quite often student tends to forget about this. 2 is common factor. You solve this, you factorize them. That would be will be minus 2 times x squared plus x plus 3 over x squared minus 3 squared. So this is how you would do, how you want to do it for u and v. Now next, really the last part of a composite function, the fifth one, F. You call chain rule for a composite function. That would be dy over dx. Just like curry chicken, I would say, in order to have curry and chicken, curry is your y, chicken is your x. You need to start off with a curry, dy, followed by dx. So you need to draw this one, and curry and chicken, cross them. Then what here and here would be a denominator should be the same, so that you're able to cancel off. You get dy dx back. There will be some other function, du here, maybe du dx. This is what you have. You're able to cancel them later. Now, for this equation to work, the question that I have here is, I think I will show you some questions on this over the application. They will normally include the rate change kind of question. A sphere increases from one to another, and what happened at the end. Say, for example, this kind of question is a bit complicated, but hope I can help you out with it. Let's say you were told. It's more towards application, but I will do it here, part 2. Area of a circle increasing at a constant rate of certain number. So area of the curve increasing at the rate. At the rate is the keyword. So whenever you have a rate with your keyword here, this rate word at the rate, that would be over time. So therefore, the area increases over time. So there will be, I would put it into equation form. That will be my D that will be my dA over dt is equal to 0. Maybe 3 pi, unit is important, cm squared per time s. So that's area over time. So it's area over time. The unit here told me that it's right. Increasing, that's why the number should be positive. So it's positive. I get 1. Find the rate change of radius. You need to find rate change. Find rate change. Rate of change of its radius. So in a mathematical form, radius is r, so I will say it's dr dt. You are asked to find out what is this. As an instant when area is 27 pi. So in order to solve it, and you heard of this kind of question, a few things I want you to do is, first of all, you need to write this down. What is this? What do they give you? What you are asked to find? And what's the area? 3 things. You have these 3 things, you're quite fit to go. So start out with dr dt, dr over dt. You need to find what? Curry and chicken. So you expect equals to, you need to do it exactly what I told you. Then you very easy. Cross first step. Then copy this to here is dr. Denominator dt, you don't write here, but here dt. Then ask yourself, based on what's given in question, what do you have? It's A, isn't it? This one here. So you will transfer that to here. So dA is common, so dA dt. So dA will be here, so that you will cancel it off. You get your dr dt. This is what you need to look for. However, you don't have dr dA. You have dA dt given, but you don't have this one. So what you do, you want to rearrange it, because you know from the general equation that you have learned, area of a circle, where A, maybe I'll use this. Okay, no, maybe I'll use this one, black one. I know A area is equals to pi r squared. So therefore, dA over dr, differentiate in terms of r, this is a constant, so it's 2 pi r. So you need to have 1 over A over dr. So what you do is when the area is 27 pi, what is r? So you find what's r, you substitute into here, you get your dA dr. So therefore, 27 pi is equivalent to pi r squared. You may cancel here. Therefore, that will be equals to square root of 27. So therefore, come back to your original question. My dr over dt equivalent to, this is 1 over dA over dr times dA over dt. So therefore, the change of dr when my area is 27 pi, that would be 1 over dA dr would be 2 pi 27 root times dA dt is 0.3 pi centimeter per second. You may just calculate to get the answer. And this is all about the second part. I know this part, last part here, would be a little bit too complicated, but you may go through this, rewind to the previous part, rewind it, watch it over a few times, and then practice on question that sounds like this, increasing at the rate. I'm sure you can handle it as time goes on. Thank you.